Hello. Now plan is to measure the efficiency of the Makita ADP05 USB DC converter that is taking the standard Makita 14.4 or 18 volt battery packs. And I'm using for the tools using this DC load as an output, and we can log the data to the computer. Then between these two I'm using another voltage current logger that I can also take the data to the computer via Bluetooth. Then of course different kind of cables between them. Maybe also in one point we use another DC load for that we can take load to the both USBs. So let's see. Let's check the specs of the ADP. So it promised that it can give 2.1 amperes to each port. So we should get at least 4.2. And does it say? Okay, this is talking about the 18 volts, but if we check the, let's see, input, do we get the reflection badly? It says 14.4 to 18 volts, but basically if these are the battery packs, the 18 volt, when it's full charge I think it's 20 volts, and when the 14.4 is empty I don't know how low it goes, but it's anyway less than 14.4. So if this device is efficient, then it's quite handy for people who have a lot of Makita tools and the battery packs. They can use this to charge all the USB devices. But if this is losing a lot of energy, then it's maybe not the handiest tool. So let's check how good it is. This is now full charged. Let's open them this way. I will open the multimeter and then let's make the measurement. This side is plus and here is minus. So yeah, it's over 20 volts. And now I need to take with the cables from, because I don't have any better tools to get from here. Okay, now we can put this one, and it's measuring about the same voltage, and I can put this straight behind this one, and then I need to connect it to computer. Then let's open the programs. Okay, so here we have the softwares. The left side is the one that is connecting with the Bluetooth. It's kind of like the front end that I'm using straight to the battery, and then on the right side we have the one that is connecting to the load, and they are showing quite same voltage. Let's see again what was the one that the meter was showing. 20.45. So the load is showing just a little bit less, but it's behind the cable, so there can be a little bit of loss. And the load, if we put 1 ampere for 1 minute, let's see, it rises to 1 ampere. Also the other one is showing kind of like exactly 1 ampere. So it seems that the measurement of the current is accurate. So now I think we can put this between them. So then I need to take from the output of this one, this one is plus, this one is minus. We can put this one here, and now we can make, okay, so now we have the first phase here straight from the battery, a little bit over 20 volts, and here is we have the after the converter standard USB 5 volt. So now we can set up the test. Let's start from 0.1. Let's stop to 2.1. Let's stop the test if the voltage drop to 4 volts and 0.1 ampere steps, and let's test always 20 seconds per step. And now I have to clear these datas and start. So now this takes some time because it has 21 steps and it's taking 20 seconds for each step. Now we can see that the DC load fan, okay, I cannot get it easier. The fan is spinning now. It's cooling down the load, and this is showing the current. It's taking a little bit less than 0.1. Let's see, the next step is probably raising it. So now it jumps, yeah, now it's over 0.1. But still if we go to softwares, it's now taking 0.4 from 5 volt. So now let's let it run till the end and let's check then. Okay, now the test is ready. I will export this one. I will export this one. And let's see if we can export this one, but let's type the ADP05. Let's put it from 0 amps, and then I will now when we have saved those, I want to do small single test still to see what is the current when we are pushing 2.1. It's taking 0.58, 580 milliamps from the battery. So now I can take another load and put it to this USB port. I'd use that one to take the same 580 milliamps, and then put the load ramping again to the other port. So let's see if I change here. So now we can take this one away. We can put this bigger load. Now I can take and now about 2.1, the display measurement, I don't believe so much, but to get here the 580 milliamps, and then I believe we have the same $570. Yeah, now it's 580. Well, it's showing 2.06, so it's quite close by. So can try to get this one again plugged in. So now we have again, and we can change this one to, now it's from 2.1 to 4.2 amps. And let's clear this one, check that we have, okay, it's losing these ones. So 2.1 from 0.1 to 2.1, got a voltage 4. And let's do it the same every 20 seconds. Then I will clear these ones and start. And now again, let's wait. Okay, it came ready and it was able to provide 2.1 from both. I will again export these ones. I will save this one. And still I like to make one test. Now the bigger load is still pushing the 2.1 amps from the other port. So I just want to test how much the other port can provide until it shuts down. So let's make clear this one, and let's still make a new test of, let's start from 2 amps, let's stop at 3 amps, 4 volts, minimum is 0.1. It would be nice to have a smaller one. I think the load can do smaller steps, but the program cannot. Let's make it 10-second steps. So let's see when it stops. So now it's taking 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. Let's focusing quite good. .7. And then it crashed. It was maybe just changing to 2.8. Most likely this measurement is not really accurate. I think it's a little bit less in truth. The problem is that I cannot put the load very well in there, but I think we can do one small test. I took the other load away, and if we put my multimeter between, so now we have the measurement. Let's turn it off, and well, yeah, it doesn't matter. Let's try it a little bit. That's a little bit. Okay. So now we should see, and also you should see in a screen the current. Let's see. Okay, it's minus, but anyway. I will ramp this near 2 amperes. And then with the finer one, let's see when it drops down. 2.1 was the promised one, so it can provide that one. 2.2. Okay, leave it over 2.3 and then it shut down. Yeah, not bad. Then have to check the Excel data. So now I have, from the primary side, I have 4 this kind of awful Excels where I have just read time, number, and then the value, and the voltages and current are in different spreadsheets, and then because I made 2 different measurements, so they are in the another one. So now I have to check when the measurement really started and remove the unnecessary stuff. Okay, new day, but now we have the measurements. So here we have the 42 different measurements out of every 100 milliamps. So we have the input voltage, input current, power calculated from those. We have output voltage, output current, Then I have a current fixed, because when we go from 2.1 and then we had another measurement, so I just added the 2.1 to the currents. So then we have the output power and output power fixed with the correct current measurement, and then calculation of efficiency from those output and input power, the difference between them. And it seems that this is like the lowest is 86%, and in the highest it seems to be 89.4. Let's a little bit zoom it. Okay. So 89.4. Kind of normal looking curve. It's always a little bit more efficient in some specific area, but the difference is not huge. So it seems that Makita has built it in a way that it's not really efficient in any area, but it's not very poor also in the both ends. So I would say it's quite good in the looking of this one. And probably even the most efficient is from 0.4 to, let's say, 1.5, and I would say that's probably the most common used area, and still like almost 87 outside of that one. So this looks quite good. Of course, small mistakes in the measurement. They are not like really accurate, but still I would say this is quite okay way to measure it. And now I was thinking that I still want to make two different measurements. Another one is that I will check that if the power in is changing if I change the voltage input. So now the whole measurement was done about with 20 volts. So it was 20.40, and in the lowest it was 20. So the voltage was about the same all the time. So now I'm thinking that I take out like 1 ampere, which is kind of like normal, 5 volts, 1 ampere, 5 watts, and then let's check the input power. Is it changing a lot when I drop the voltage to 14, 13, whatever is the point when it's not working anymore? It officially says it's 14.4, but I think the 14.4 is the nominal voltage of the battery pack, so probably 13.5 or something like that. That it should work at least. I don't know, it can go really low. But it's possible also that this one is trying to protect the battery pack, that it doesn't go so low, but in an 18 volt battery pack it would be too low anyway. So hard to say how they have made it. And the other measurement that I was thinking is to measure how much we can pull from the 6 amp hour battery pack. So I will make the measurement, but that measurement is taking the whole night, so I just put it running for the night, and in the morning I can see the result. So let's see. Okay, so now we have the DC load and the converter. I have the voltage current measurement, and then I have the voltmeter connected, where you can see on the left corner the green measurement, and then I will supply the voltage with my Agilent E3631A triple output DC power supply. This can give up to 25 volts, from the output. So I think we start from the 20 volts. I don't want to put over voltage because I don't know how the Makita has been protecting that one, and it's not my own one, so I don't want to destroy it. So we can start from the 20 volts. This is a little bit noisy power supply, but let's see now 25 volt. Let's see, and yeah, I have already also connected the, let's see, yeah, it's measuring. Okay, now about enough. Okay, it's 4 volts is not enough for the measurement, but let's see, with 5 volts it's starting. But now we can supply 20. Webcam. Okay, so now we have 20 volts. My multimeter is showing 20. This one is showing 20.06. And okay, then let's open the softwares. Here. Let's see, I think I have to connect this one again. Okay, let's see, I disconnect. Okay, now it's showing the output 5 volts. I think we clear these ones. Even I'm mostly watching this power. When the voltage is going down, is the power staying about the same? I think this one is also disconnected, yeah, because it was off. So let's see. Okay, now we have a connection. Input is 20 volts. So let's see, we can make, let's take like 10 minutes, 1 amp. I think 1 amp is anyway probably the most common output that you take from these ones. It's very common for multiple devices. Even nowadays many devices can take 2 amps, but so let's start. The current I will change. Let's change it to 1 amp. And now it's taking the output is of course 5 watts, and the input is 5.570. It's a little bit jumping all the time. So let's see now. Let's drop the voltage slowly and see if it stays about the same. Seems to stay quite well. Now we have 17 volts. Well, I have a half an volt drop in the cables because I have quite thin cables, so 15 volts. The power seems to stay quite nicely. It's even a little bit dropping, so it's a little bit more efficient in a lower voltage. But the difference is not much. So now I already have 14 volts. Now I will a little bit, let's drop only 100 millivolts at a time. So we can see when it's okay, already crashed at 13.8. So I don't know if you can really push 14.4 volt battery pack to empty with this one. Maybe someone who has those battery packs can say what is the minimum voltage of those smaller packages. But the good thing was that the power was staying at the same or even a little bit more less power when we drop the voltage, so it seems that it's a little bit more efficient with the lower voltage, but not much difference. But at least with the 18 volt package we should get it empty, and the efficiency is not dropping from those ones that we measured earlier. So that seems to be quite nice. So now I take a full battery pack and I put it empty. Okay, so we have 20.5 volts, it's fully charged, and now I have to decide what voltage I used. So I'm calculating the capacity. Let's connect this one again. Clear these ones. Clear. Clear that one. And okay, now the problem is that I have to put the timing. Can I really put as long as I want? Or do I have to put the other DC load? Let's see, does this allow? Let's see if it doesn't complain about this one. 4 volts out of range, 999. It's still how many hours? 16. 6 amp hours. Well, if we push 2 amps, it should be okay. So let's clear this one. Let's see. I hope it's not too much for the small load, but then if it breaks, then it will break, but I have to a little bit monitor the temperature. So let's see later. Okay, we have measurements ready. I was a little bit trying to push more, but the voltage didn't rise anymore, so it seems that it's empty. So we get 4.8, 4.9 amp hours from the 6 amp hour package, but I'm not totally sure how fresh package it is. And we did get 88.45 watt hours, and the voltage was dropping linearly, so of course the current was also raising the same curve, so the power was steady all the time. And we did get 76.52 watt hours from the DC converter. So if we calculate the efficient, let's calculate. So 76.52 divided by 88.45. So 86.5% with 2 amperes. And if we check our calculation, 2 amperes was 87.1, 2.1 was already 86.4. There is a little bit error, so let's say we were just in the same values. And also now we were emptying the whole package, so the voltage was going down from over 20 volts to down to, let's say, 18. Well, I don't know exactly how, but it went anyway down, and now there is any more 14.4 volts. So the conclusion was that the efficiency seems to be between 86–89%. It's quite steady of the whole output. A little bit more efficient in the 0.5 to 1.5 volt amperes. And then the voltage input didn't change the efficiency. It was kind of steady the whole line. And maybe the one, well, okay, and it was able to push the promised 2.1 from both USBs at the same time. A little bit more, let's say 2.3, but at least the promised 2.1. And the only thing that I'm a little bit thinking that, can this empty the whole 4.4 volt package? And because it was cutting in 13.7, if I remember right, and I don't know how low the 14.4 volt package really goes. The interesting thing is that in Makita USA website, they are selling this only for 18 volt packages, battery packages. But in Finnish website, they are saying that this is suitable for 18 volts and the 14.4 volts. So here is the Finnish Makita website. So here in the headline it's saying 18 volts, and in here it says that charge your phone with the Makita 18 volt battery. But then here it says it works with Makita 18 volts / 14.4 volt, and also here we can see the icons of 14.4 volt, 18 volt. But then when we check the technical info, here it says 18 volts. So maybe this is just a mistake in Makita website, and it shouldn't be promised for 14.4 volt batteries. I don't know. Other than that, or let's say if you are using the 18 volt packages, this seems to be quite good device. The price in Finland, I think it was about 30 euros, so it's not too bad. It has quite nice clips, so you can put it in the belt, but of course, like at least these 6 amp hour packages are quite heavy ones, so probably you don't want to carry that kind of for a long time. But smaller packages with this, you can charge your phone multiple times, or flashlights, or whatever you are using it. So I would say this is quite nice handy device. Okay, thank you. So moro.